All right, let's walk you through a problem that's a little bit larger. This problem has 3 decision variables and it has 3 constraints. So let's take a look at, let me highlight this to kind of separate it from all the other print there. Okay, so we want to solve this problem where you're maximizing p equals 4x1 plus 3x2 plus 2x3. And you're given 3 constraints that are less than or equal to a non-negative number, and you have your non-negative constraints. So this is a standard maximization problem. Now, we first write the initial system. So add S1 to the left side of the first constraint and convert it to an equation. Add S2 to the left side of the second constraint, convert it to an equation. Add S3 to the left side of the third constraint and convert it to an equation. And then from the objective function, move all of your terms to the left and they will change to negative values. And then you'll have plus p equals 0. Now, I know all of the problems that I've had so far, the numbers on the right have been positive, but don't be shocked if you see an objective function that has a minus over here. And all that would change is when you moved it to the other side, it would become positive. So, you know, it is possible to have a minus on this side of the equation over here. All right, now I'm going to put this in a tableau. So let me highlight that for you so you can see the tableau. So here's the tableau that I'm going to put it in. So notice I've identified the columns for x1, for x2, for x3, and then for S1, S2, S3, and P. These kind of got shifted a little bit, but these are the columns. And then, so I just put in the coefficients of these variables. So from the first equation, I have 3x1 plus 2x2 plus 5x3 plus S1 equals 23. The second equation is 2x1 plus x2 plus x3 plus S2 equals 8. The third equation is just 1x1 plus 1x2 plus 2x3 plus S3 equals 7. And then the objective function converts to negative 4x1 minus 3x2 minus 2x3 plus p equals 0. Now, if you take a look at this problem, you can see that the most negative indicator is in this first column, negative 4. So negative 4 is the that identifies column 1 as the pivot column. And then you divide these positive numbers up here into their constants. So 3 divided into 23 is actually 7 2/3. 2 divided into 8 is 4. And then 1 divided into 7 is 7. So since 4 is the smaller quotient, then that tells me that I'm going to be pivoting on the second row, which tells me that since the second row intersects at this 2, it intersects with the pivot column. So the pivot row and the pivot column intersect there at 2, then I need to pivot on that 2. Now, like I did before, I'm not actually going to go through all the operations. I'm just going to tell you what's going to happen if you complete this one pivot. So if you complete this one pivot, you're going to have to multiply this row by a half. So there's that operation, 1/2 row 2. And then after you've done that, so go to scratch paper and multiply this row by a half. And then after you've done that, you're gonna actually have to multiply this row by negative 3 and add it to this row to cancel the 3. So that would be that row operation. Then you're going to have to multiply this row by negative 1 and add it to row 3. So that would be that row operation. And then you're going to multiply this row by 4 and add it to row 4 to get rid of the negative 4, and that would be that row operation. Okay, so go ahead and do those row operations on scratch paper, and then make sure that when you do those 4 row operations I gave you in the order that I gave them to you, that this tableau actually transforms into the tableau that I've given you down here. Now, let's look at the tableau down here. Now, I only have one negative indicator, so that means that this column has to be the pivot column. And then all of these numbers are positive, so divide each of these numbers into their constant. So 11 divided by a half would be 11 times 2, which is 22. 4 divided by a half would be 4 times 2, which is 8. and 3 divided by half would be 3 times 2, which is 6. So the smaller quotient identifies the third row as the pivot row. So there's your pivot row. And so that means that I'm actually going to pivot on the 1/2 that's in the second column, third row. So now to do that operation, what I've got to do is I've got to first multiply this row by 2 to make this a 1. So I'll do 2 row 3, and so I'll replace row 3 with 2 times row 3. And then after I've done that row operation, again you can go to scratch paper and do this, but after you do the row operation you'll get a 1 right here, and then you can multiply that row by negative 1/2 and add it to this row to cancel the half there. Then you can multiply it by negative 1/2 and add it to row 2 to cancel that 1/2. And that would be these two row operations here. And then to get rid of the negative 1, you can just take row 3 and add it to row 4, and that will cancel the negative 1. And now notice here that when we finish this problem, let's see, I don't see any negatives on the bottom row. And let's identify our basic variables. I see 2 basic variables here. I see another basic variable here. See the 1 and the zeros? And then of course P, as I told you before, always remains basic. So it turns out that x1 is basic, x2 is basic, s1 is basic, and p is basic. So that means x3 never entered. x3 remained non-basic. So x3 is going to be 0, s2 is going to be 0, and s3 is going to be 0. So if you wipe those columns out, if you wipe out the x3 column, wipe out the s2 column, and wipe out the s3 column, then your first row is going to give you, where is it? There it is. S1 is 8. Your second row is going to give you that x1 is 1. Your third row is going to give you that x2 is 6. And your fourth row is going to give you that p is 22. So putting all that together, I know that p is 22 when x1 is 1, x2 is 6, x3 is 0. Remember, x3 was non-basic, so it's 0. And then if you want the values of the slack variables, s1 would have to be 8, and s2 would have to be 0, and s3 would have to be 0. Okay? So again, x3 never entered, so it's going to remain as 0. So that would be your optimal solution for that problem. So on the next video, I'm going to go ahead and set up and solve some application problems, in other words, some word problems for you, so you can see some practical applications of this linear programming process.